Hey guys, it's Udbhav from team 19343. This video is a continuation of my FTC programming course in Android Studio. Today's video will be on our second physical component, the motor. This video will include what a motor is, different types of motors, how to code motors, and game-relevant applications of motors. Like with servos, we will be using linear op mode to demonstrate the servo coding. However, the difference between op mode and linear op mode is fairly negligible in this case. A motor, in the context of FTC, is a relatively larger component, so around 5 to 6 inches, and it's a tall cylinder, and rotates continuously in one direction or the other based on the code given. The rotations per minute vary between the types of motors and are generally used in motion of larger compounds. So, for example, motors are utilized when powering the drivetrain of the robot, which is essentially the leg of the bot, which allows it to traverse the field. We will be covering the mechanism drivetrain in the next episode, so stay tuned for that. Now, let's move on to the coding aspects of the motor. So just like the servo, we need to follow the same logic of coding for the motor. So let's identify the class, give the variable, and then name it. So it's a lot on screen right now, but I'll systematically explain each and every part of it to you. So after we initialize the motor, we can now give the commands. So there are 5 main commands we can code for a motor: the direction, the speed, zero power behavior, the set position, which is used in encoders, and set velocity with encoders as well. So to code a certain direction you want to have the motor rotate, simply insert this line and give the reverse command. So as you can see, we have forward, right? So if you want it to go the other way, you can just do reverse and it'll rotate the other way. So this will cause the motor to rotate in opposite direction. To set the speed of rotation to a motor, give the set power command and set the value between -1 and 1, with 1 being the highest speed in a direction and -1 being the highest speed in another direction. Next, we have the set zero power behavior command, which basically dictates how the motor acts when a zero power input is given to it. So for example, let's say we code the motor to rotate when we hold the gamepad button A. Zero power behavior dictates how the motor stops when we disengage gamepad A. This behavior can be given with either a break or a flow. So with the break command, the motor will stop rotation instantaneously, giving no further rotation. This can be used in drivetrains to prevent drift and allow for more accurate movement. Meanwhile, the float command lets the motor naturally slow down from its rotation speed until stopping. So let's example say I want to make it brake. Simply go to the end, click brake. Also, generally when you're coding, this entire part will not come. It's just been coming for an unknown reason. So don't worry about it, you don't have to type all that out. For the set position and set velocity commands, we need to understand the different modes of the DC motor as well as the DC motor X component. Let's move on to the different modes we can set the DC motor to. First, we have the run using encoder method. An encoder is a physical component, which when plugged into the motor, keeps tracks of how many rotations have occurred using the unit of ticks. By setting the DC motor to run using an encoder, it ensures that A, the motor runs at a consistent speed regardless of the battery, and B, allows it to use the set position command, as the encoder keeps tracks of the motor rotation through ticks. The set position command allows the motor to only rotate to a certain extent, making it very useful in moving larger components precisely. So for example, take large linear slides. And let's say, for example, in this year's game, Into the Deep, we want to keep the pixel or the sample into the basket. We can use an encoder to set it to the position of the wastebasket. Next, we have the run without encoder, which doesn't really have many uses as it's the same as running the motor without setting the mode. Finally, we have the stop and reset encoder mode, which resets whatever value the encoder may have to 0. Now, let's discuss the DC motor X component and the command unique to it, setVelocity. So to initialize this motor, it's the same method as with the DC motor, just with the class DC motor X. It can execute the same command as a normal DC motor, but it can execute one additional command, the setVelocity command. This setVelocity command is a more accurate version of the setPower command, as the measuring unit is in ticks per second. The values are not limited to the set power command and allow the motor to rotate at more precise speeds. So with the set power, we're limited by -1 to 1, but with the set velocity, it's basically ticks per second. So I can set it as either 8 if I want a really, really slow rotation, or maybe 150 if I want a faster rotation. Well, that's it for today's video on motor coding and uses for FTC Java programming. I hope that you now have a comprehensive understanding of the uses of the motors, their different types, and how to code the same. Stay tuned for next video in which we will learn about drivetrains, specifically the mechanism drive, and how you can code it for your bot. This is Udbhav from team 19343, signing off.